Welcome to this Bakerpedia seminar, all about securing dough quality in a changing industry. I'm Mark Flurker, your host for today. This seminar is brought to you by KPM Analytics. KPM Analytics supplies instruments that measure critical quality parameters of incoming ingredients, analyze products during the baking process, and ensure final product quality. Their comprehensive range of analyzers are used by food producers throughout their production to improve efficiency, ensure quality, and protect their brand. KPM Analytics is backed up by 100 plus years of experience developing advanced products and processes for quality assurance and process control in baked goods manufacturing. If you need any Q&A help, kpmanalytics.com is the website you need to remember. Today, we are joined by Lena Bosch-Biana. Lena Bosch-Biana has an education in engineering and food science, specializing in the cereal industry. She works for Chopin Technologies, part of KPM Analytics, since 2014. For more than 9 years, she has occupied different positions and now manages the food, products, and applications team, whose role consists of ensuring the application development and promotion of Chopin products. They provide personalized solutions to customers willing to improve control of their products and processes. Lena's responsibilities also include the standardization of the developed methods, working closely with various associations such as ISO, the Industry Standards Organization, AACC, also known as Cereal Grains today, the American Association of Cereal Chemists, as it was known before, and ICC. Now, let's dive into dough quality as Lena will share a presentation.
Thank you so much. This is really a pleasure for me to be here today and to speak about this fascinating topic. I'm actually very proud to present it today because we feel that is going to be key in the next few years. So let's dive into it. So this seminar is entitled From Expertise to Data, Securing Dough Quality in a Changing Industry. So obviously here the industry I'm talking about is the baking industry. And when we say it's changing, is that, well, it's very well illustrated by a couple of facts and by, I would say, the impressive evolution of the baking industry since a century. In just a century, we went from really craft bakers, just maybe reunited in one location, and that was an industrial bakeries, but this is still a reunion of craft bakers, to a strong automatization of the lines of production. And that is great. That is great for throughput, but that means also that these lines, they are less, well, they cannot adjust automatically, at least. If the flour quality is changing, if the dough quality is not the same, if you have some stickiness, if maybe the dough is tearing apart, the craft bakers, well, there are maybe 10 people on those lines. Of course, if you're considering the complexity of these lines, everything starts to stick together, this is just a nightmare. So quality control is just getting more and more important to ensure that the process is running smoothly. So that's the first thing. And then there is a second thing that is going on a little bit at the, well, it has been a global trend and it has been globally accelerated since COVID, is that those master bakers who know intuitively what to do when the dough is not as usual, if the dough is a little bit too firm, like they see the dough and they know, oh, I need to put more water. Oh, I need to increase the dough resting time. And yeah, they touch the dough and they know, and this is magic. But the thing is that those people, they are disappearing a little bit from the industry. We are seeing it all over the world. Those people are retiring, and the thing is that they are fewer young people that are entering the market with the same wish to spend maybe a decade to learn how to touch the dough and get this level of expertise. And this is just so difficult to transfer this expertise, like to train another master baker to feel the things the same way and to train him into having the same adaptation in case it doesn't work. So there is a need right now to put objective data on those feelings. There is a need to complement bakers, the master bakers' expertise with real data. Okay, I touched the dough, I know it's good. What does that mean? How much is it good? And then there is another thing. It's a tendency that we always had, and maybe it was true century ago, to use the same, to think that the same type of flour can accommodate the different types of processes. To see, like, if we ask ChatGPT what is the best flour for making pan bread, it will give us an idea. It will tell us the protein must be between 11 and 13%. Wow, that's very impressive. So I just need to make sure that I have everything in those tolerance and everything will be good. Or you can find the same kind of, yeah, that would be, I mean, that would be amazing as well. But the truth is that, you know, just like I do, it doesn't work. And like you can find also in the literature in everywhere, really, like this is baking business, this is a serious matter. Baking business telling us that for making a white sandwich bread, we need a protein content between 10 and 11.5. You'll notice that it's not the same already. But we have those ideas that for making a good pizza, then you need a farinograph water absorption of this, and then you need an alveolograph like that. And then you also have consultants, like people who know the product, who come to you and who tell you, oh, to make this kind of product, you need this kind of flour. And I know it because I read it and because I tell you. And this is what we like
read it on Reddit.
Yeah, this is highly theoretical, but this is what we call a flour guru. If it works, great, the flour guru will have make it work correctly. But if it doesn't work, then you can say, oh, it's because the process is not okay, or it's because this or because that. And the truth is, we believe that no one can tell you that you need this kind of flour. We have been working at Chopin. We have, as you said, Mark, as an introduction, we are backed up by a century of expertise, and we are not able to tell anyone just by knowing the final product, this is what you need. Because this kind of advice, they do not integrate the reality of each baker. They do not integrate the fact that each process and each final product is unique. And when it comes to the final product, yeah, we can mention, so here there is an example about pan bread, but we can also, an example that I like is about pizza. You want to make a pizza, so you go to the literature and you need a flour that is like this or like that. But what kind of pizza are you making? Are you making a pizza from Napoli or a pizza from Chicago? Is it really the same flour that you need? And then even two people that are making the same type of final product, like two pizza, Napoli style. Well, this is very probable that those two companies, they are not using the same process. They do not have the same machine. They do not use exactly the same formulation. They do not use the same process with the same times or the same temperatures. And then there is the human factor. Even within one company, sometimes we can see a shift in the results just because this is just another, new operators on the line. So there is many variables between the flour and the dough. And so this is why we think that we cannot say this is a good flour for making this. The only thing that we can say is that flour quality should be specific to each baker and taking into account the final product and the process and the formula. There is a tendency to try and predict from flour what will happen with the final product. I have a flour with W like that and water absorption like this. And so I know that the final product will have a volume like this and that. This is basically what everyone wants. But flour is just a base. If you don't know the ingredients added to it, and if you don't know the process and how it affects the dough, you cannot really predict the outcome. So our idea is to focus a little bit on what we like to call the missing link. Like, we're able to analyze that, but then in the middle you have the dough. And the dough is a little bit what we miss here in order to have a maximum information, to understand the recipe and to understand the process. And so our idea was to, well, we have worked for a very long time, really. It's been more than a decade now, on solutions to try and start to analyze the dough. And because we have worked in partnership with industrial bakers, because we have learned from our expertise, we have been able to gather all of that and combine it into one solution that we have just launched into the market, and that is called the Mixolab 300. So the Mixolab 300 is a brand new equipment that is designed to analyze both flour and dough. So maybe just a reminder of what a Mixolab is, because the Mixolab is not new. It has been on the market for several years, several decades even. The Mixolab is a machine that measures the evolution of the consistency of the dough during mixing, which is a little bit the same thing as a farinograph. And then it will change the temperature. And by changing the temperature, it will allow us to access more information about how the gluten reacts to this increase in temperature, and so how it may affect the volume. We will see how the starch is gelatinizing, depending on the temperature, and that will directly impact the structure of the final product. We can see the amylase activity, which may impact the color of the final product, but not only. And then we will decrease the temperature. And by decreasing the temperature, we simulate the end of the process when we take the bread out of the oven and we let it rest on the counter. If we have a strong, then we measure the retrogradation of the starch. If we have a strong retrogradation, we will have a short shelf life, and the other way around. So this is a really complete information that we have on the flour, and not only on the protein, because this is also very interesting to realize that in our labs today, most of the analysis that we do, they are mostly focused on protein. Like you take farinograph and extensograph and alveograph and glutamatic and a little bit of mixograph and maybe this and this and that. But this is all about protein quantity and protein quality. There is, in the end, very few methods that are used in a daily basis to analyze starch. But starch represents 72% of the flour. So yeah, and it's not like starch is not functional. Starch is highly functional, and it will impact every aspect of the final product and a lot of aspects of the dough. So measuring starch is really important, and the Mixolab can do that. And it's not only measuring starch, it's also measuring starch in conditions that are close to the reality, because there are ways of analyzing starch, such as the RVA or the amylograph or the ViscoQuick and those kind of equipment. They all work on slurry, which is good if you want to see the starch full potential. But bakers do not work on slurry, they work on dough, and a dough is a place of intense competition for the water. So we believe here that because we work on a dough system and not on a batter, we are working in a system also more representative of the reality of the baker. And we can summarize this information in a very nice spider web that makes it very easy to use in a quality control system. So that's the basic of the Mixolab. And then recently we have launched the Mixolab 300. And the Mixolab 300 comes with additional possibilities. And the main additional possibility is the possibility to analyze the dough. So how do we make that possible? How do we make that the Mixolab now is able to analyze dough? This is thanks to 3 different tools. The first one is a dedicated mixing bowl. So this is a watertight mixing bowl. So that means that the Mixolab 300 comes with 2 types of mixing bowl, one for flour, this is the standard mixing bowl, and one that has been completely tightened to work on every type of dough, including liquid dough, including batters.
Oh, wow.
Yeah. FYI, there is a patenting procedure for this tight mixing bowl. We have designed a specific introduction kit to make sure that we can introduce easily any type of dough from very hard to very liquid. And there is a dedicated software, which is a true companion to really analyze the results, because the data without, well, something to analyze, it is just data. So we also wanted to provide the analysis function, let's say. And of course, the Mixolab 300 comes with a flour mode to analyze flour and a dough mode specific for dough analysis. So I will try and describe a little bit all of that in greater details, starting with the introduction system. So here you have an overview of the introduction system. This introduction system is easily removable in order to ease up the cleaning, either in between tests or at the end of the day. It also comes with specific accessories to help with the management of the dough. So we have a specific water injection nozzle. So this is for flour, but with a specific shape to accommodate with the size of the chimney here of the introduction kit. And then we have specific accessories such as a flour funnel, a brush, and most of all, a pushing tool that is going to be super useful with some types of dough. So how does that work concretely? Well, this is extremely simple. You take a piece of dough from the line of production, you weight it, and you introduce it directly into the Mixolab. Then you put the pushing tool on top of it to make sure that there is no water evaporation during the test, and you're good to go. And it works for any types of dough, including the most challenging, and for any kind of consistency. Here we have an example of on pancake dough, for instance. And if you have some remaining dough on the wall, then you use the pushing tool to push all of that in. And same with cake dough, a little bit more consistent, but still quite liquid. And then we have tested crumble dough. And here we have used the flour funnel to introduce it. But we could have done it. We have done it also on biscuit and crackers and some more consistent dough. And if you are able to have all of that together, you just introduce all of it together. That works very well. And up to the most challenging dough, here we have made on purpose a very sticky dough. So of course, the introduction is a little bit more complicated, of course, but still, you can see that we can put all of that in, use the pushing tool, just remove it to see there is nothing left on the wall and everything is introduced into the mixer. So that really works for any types of dough. And the most interesting thing is that, okay, we are able to analyze dough, to put dough in the Mixolab, but what about the results? So this is the results that matter in the end. And if we look at the results, well, we do have very good repeatability for any type of dough. We can see that every time we have two curves and they are very well overlaid. And if you look at the global here comparison, we have very good discrimination in between dough. All right, so that's let's say a first step. Now let's dive a little bit more into the possibilities of analysis. And this is done thanks to the new Mixolab software, which is called the Mixopro. And yeah, so in order to analyze the results, we have developed a new software that's called the Mixopro. And the Mixopro comes with two modes. The first mode is the flour mode. And for those of you who may already know and use the Mixolab, this is the same as before, same functionalities, same possibilities. We have possibilities of making variable temperature tests, such as the standardized one, the Chopin Plus, and access a broad range of functionalities, such as blending low options, such as the profiler, the spider web that we have seen. We can do custom protocols to adjust to any types of products, gluten-free, protein packed, starch, whatever. And then we have other types of protocols, such as the Chopin S test, which is a specific test to predict farinograph results. And then we have additional tests, such as test at variable speed or test hybrid with both temperature and speed that are varying at the same time to really accommodate for a maximum of possibilities. The real novelty is the DO mode. So there is this entire new mode that has been created to work on DO. And here we have two main options. We can work according to two possibilities. The first possibility is what we call an instant consistency test. So it's a very short test, a couple of minutes maximum, to just assess the consistency of the dough at this moment, to put a number on the baker's expertise. And that's really the best option here for quality control, process monitoring. And then there is another option, with what we call the full test, during which we will increase and decrease the temperature to access a maximum of data. And I will give you a couple of examples of those two possibilities here. So about the first one, the instant consistency, the idea is really to, again, with those master bakers disappearing a little bit from the workforce, what we want to do here is to put data on when they touch the dough and they say, oh, this is a good dough. We want to know what does that mean? And to do that, the first thing is that you have to learn. You have to learn because every dough is unique. So we don't have like one protocol. This is the protocol for making crackers dough. This is the protocol for making crepe dough. We cannot do that because every dough is unique. And so in the software, there is a learning mode to guide you in creating your own protocol. The second step, once you have your protocol, is to create your specifications. Basically, you just analyze good dough that the master baker is saying, oh yeah, no problem. No problem during the production line. No tearing, no stickiness, and final product conform. This is a good dough. You take all of those good dough and you say, oh, the minimum was there and the maximum was there. This is your specifications. Once you have your specification, then everyone can use the Mixolab very easily. Even an operator with a limited training can just take a dough from the line, place it into the Mixolab, and at the end of the test, the result will be displayed according to your specification. Either it is in green and everything is okay, or it is in red, and if the operator is not so trained, he can at least raise his arm and say, oh, I think we are going to have a problem, and go to the master baker for correction. And then you can put all of those data into control charts. And that really is the best way to make links with your process. Like all of a sudden, there was a shift in the results. What changed here? Was it a new operator? Was it a new batch of flour? Was it a new batch of ingredients? What was it? Then you have the first base here for understanding what affects your process and so on, what you can play to correct. And in the end, I just wanted to illustrate by giving you a couple of real-life examples. So here, this is results that we have obtained for a donut production, for a donut manufacturer in the UK. Here, what we can observe is that the discrimination is very obvious. In 2 minutes, in only 2 minutes, you take the dough from the line, you put it in the Mixolab, and 2 minutes later, you are able to say, this is going to be okay, or this is not going to be okay. Even that here, not okay, was meaning that this is not a real picture. It's just a picture I took from the internet.
You have the information before the donuts even start to get cut.
Yeah. But yes, that's the idea that in the end here the donut was the hole was deformed most of the time. That was the problem, and that's in 2 minutes you are able to say it just at the end of the mixing step. And here another example, maybe a little bit less impacting because the discrimination is not so obvious. But I really like this example because it illustrates a couple of things. The first thing is the importance of the learning mode. You can notice here that this here takes 6 minutes. We require 6 minutes to really get to the maximum point of discrimination. Mm-hmm. And then here, for this was a production for making crackers. Here, the discrimination between good and bad is not so obvious. is not so obvious, but the real difference between here and here, between the donut production and the cracker production, is that for the donut production, the experts, operators on the line, they were feeling the difference. They were feeling at the end of the mixer, oh, this is going to be good or this is going to be bad. So the idea here was just to put data on this feeling.
Well, also, I mean, what I see right away too is that where you have, while it is a longer time, the 6 minutes, you have a variation of 0.3 nanometers. And, there is a much bigger difference because it's only a shorter time and there's only a variation of 0.1 nanometers, right? So if
That's
you
true.
get this much difference on the donut with 0.1, as much as those lines look close together, there is a difference that is 3 times greater than even on the donut.
That's true. I like your interpretation. But yeah, no, this is actually very good.
Sometimes we have to look at the numbers besides pretty pictures.
I agree. I agree. But here, what was very interesting, so the discrimination is not perfect, and sometimes
Yep.
good can be identified as bad. But really, here, the qualified operators on the line of production, they could not feel the difference. And I went to visit this company, and they made me touch the dough a little bit, and they say, "Oh, feel the difference. This one here, and this one 1 hour after resting." And they say, "You feel the difference?" And I was like, "No, I don't feel anything." And so those people who have this amount of expertise on just touching a cracker dough, they are unable to tell us at the end of the mixer is going to be good or is going to be bad. The Mixolab can.
Yeah, I had a very similar experience not having equipment available to me, such as the Mixolab, but I was in a plant making corn chips, and we were trying to replace the majority of the corn masa, with bean powders. And
Okay.
we ended up having to make like 3 batches because it was all by feel, right? And unfortunately, I never got to feel the control, the standard of what they make. So we had to rely on the other workers there who knew what they were looking for because we had no other reference.
Yeah. Yeah, that's it. That's a little bit the point, to get the reference. What
Yeah,
is the
this is
reference?
then much faster, much more helpful, and you can actually adjust the dough on the fly.
Yeah, and exactly. And if you are too, in this case, if you are too high, or in this case, if you are too low, then you can also test maybe at the lab level what is necessary, what is required to go back from bad to good.
Absolutely.
And you can develop troubleshooting guides quite easily and based on objective data. So yeah, we believe that is very, very
I love
powerful.
objective data. I'm a big fan of objective data.
And we do too. But yeah, in any case, the beauty also of this system is that we have the results very fast. And so that's perfectly compatible with production speeds. Even if you're doing like 1 mixer every 15 minutes, that's you can manage that. And then in the end, nothing prevents you. So those were example taken at the end of the mixer, but nothing prevents you to do that all along your production after each key step. So the key steps must be determined individually for each production. But we have a customer who did that in, where was it? In Argentina, I believe, in Chile. That was in Chile. And basically what they have is that they have specifications on their flour with the Mixolab. They have specification on their dough after mixer, after division, after proofing, after this and after that, after each key steps of the process. And because of that, now they are able to just know where the difficulty is coming from. No problem on the flour, great, let's go ahead. No problem after mixing, perfect, let's pursue. Oh, all of a sudden, after proofing, I have a dispersion of the results. So that means that whatever happens between mixing and proofing. I know where to look for. And then another option, which is maybe even more powerful, but more a little bit longer, is to really enjoy the full capacity of the Mixolab and to heat up and cool down the dough in order to access the maximum of information. You can see the process impacts not only on the protein part, but also on the starch part, and everything that can impact starch properties. And also you can see better how the different ingredients interact together, which makes it easier to develop new formulations, to improve them, to develop new products. So that can really be interesting here option, let's say a must-have for R&D. And just to illustrate, I wanted to give you two quick examples. First one here about egg quantity into cake batter. So we all know the situation with egg price. This is frightening, and this is the case now. This is very much the case in the US, but it's starting to be a little bit the same all around the world. And in some formulation, some producers, such as cake producers, they use a lot of eggs. So if they want to keep their margin without increasing too much their price, they should start to look for egg replacers. But the thing is that egg is highly functional as well.
Mm-hmm.
It's not like a filling. It has function at low temperature, it has function at high temperature, it has function all over it. And here the idea was a little bit to illustrate that. So on the same formulation, we have changed the quantity, the ratio between egg and flour. And well, in orange here, you have our base result. This is our target. This is what the normal behavior is. And then if you remove egg, well, the consistency is going down. So what you can do is that you can try with an egg replacer, for instance, to go back to your target, to go back to your reference. And at least you make sure that functionally speaking, you have the same behavior as before.
Mm-hmm.
And so that can be extremely powerful into limiting the need for baking trials, because in the end here you can do the full NPD process on the Mixolab and just validate with the baking test. Or fine tune. A second example here was one with which we worked. We worked on this one with a cracker manufacturer in Italy, another cracker manufacturer, a lot of crackers. We like crackers. And well, the issue here is not really an issue, but they are working with a cracker formulation that requires a very, very long resting time, up to 15 hours resting time. So that's very long. And what they wanted to do is to decrease this time from 15 to 9 hours.
Mm-hmm. Well,
that's a lot.
Yeah.
But so they have tried to just stop the resting at 9 hours and just keep on with the production, but obviously the dough was not rested enough, and so it was not laminated. During laminating, it was not like spreading as usual. The crackers were too thick, and not the diameter was not high enough.
Mm-hmm.
And the color was off, the texture was off, everything was off. So obviously they needed to correct something to go from 15 to 9 hours. So what they did is that they analyzed their dough every hour or every 3 hours in this example with the Mixolab. And they followed up with the consistency. And what we see is that during mixing phase, we have a weakening of the dough, which is perfectly logical. One, the gluten is resting, is relaxing. And also, if you look at the formulation, you'll see that you have proteins in the mix.
Mm-hmm.
Yeah, this is a logical behavior. But if you stop here, then you miss the information that you have here. Oops, sorry. Starch, again, is highly functional. And a curve like that or a curve like that will not, dough like that or dough like that will not give the same final product, that is for sure. You have change in the gelatinization intensity, in when it happens. You have change in many aspects of the starch quality. And we can expect that also because you have amylase in the formulation and other ingredients that can interact with starch. And so the point here, by getting this amount of information, we are in a better position to correct based on sound data, on complete and sound data. So that's really a powerful tool.
That's awesome.
It is, right?
It is, it really is. I mean, especially with crackers, it's always so complex, right?
Yeah. No, and honestly, everything that we have done so far is just proving again and again that we have every interest to rely more on objective data. It can be so powerful.
Mhm.
And really that's already a good conclusion. So thank you. But maybe just as a final word, I just wanted to share the modern ID, the modern quality control in which we believe. We believe that we should try and predict less. We should measure more. We should base our interpretation on data, a maximum amount of data. And it should start with the end product. We should start by looking our end product objectively, if possible, objectively, that's even better. If you have real performance of the entire production, if you know how much you have rejected and why, was it the color, was it the diameter, was it the sesame seed repartition on the bun? Why did you reject the product? If you know why, you are in a better position to also react and to also correct. And here in KPM, we have the luck really to count on other companies such as iPro System, who have vision inspection system that you can couple with rejection system in order to make that happen. So you can measure the final product really reality. And then you can move on one step, you can analyze the dough during the process. You can understand how the recipe and the process impact the final product by running a full test. But you can also just define the dough characteristics at key points of the process and very quickly and follow the consistency of the dough. Then you can define based on observation, not based on literature, not based on what a consultant can tell you, not based on just it is because we have always done it this way. But really based on what you see in the process, define what is the best flour and give this information to your miller. And the miller will be happy as well because they will know on what to focus. They will maybe spend less time to do 1,000 analysis and make sure that everything is in the tolerance, because maybe we spend too much time worrying about something that will not affect the quality and not enough about stuff that we just don't see. And all of that you can do with the Mixolab 300. So really with this tool, you have access to a lot of possibilities and a lot of data. And here, this is what you can see at every step. We are gathering objective data. And to open a little bit the debate here, if we have, well, data is the food for artificial intelligence, and clearly artificial intelligence is going to be the next revolution in our sector, in every sector. So get ready for the next revolution, start measuring, because if you can measure, then you can improve. If you cannot see it, you are blind, you cannot do anything. So measure it, improve it. And if you need help with that, we would be very happy to help. So thank you very much for your attention. And I hope
Excellent. I mean, we need a big applause, a background sound for these things. I mean, that is fantastic, Lena. Thank you so much. This is like super informative. I'm really glad that you used the cracker example because I mean, we are very, very familiar, most of us, with the Mixolab and Farino Graph, etc., with bread doughs, but it's to see that used also for different types of doughs and the batters and everything. That is just excellent. That is such a wonderful tool to have. And like in that example I mentioned with the corn chips, I mean, I wish we would have had a lab there with that instrument there, because it would have saved us so much time and we would have gotten something done. Instead, I was there till midnight and we barely made a few crackers, right? I mean, it was crazy. I think it's a combination of training in both areas in that sense when it comes to the larger processors and so on. A different example I'll use is I was brought into a bakery to help as technical support on a very specific product that was being produced. And the people who were all there who formulated the product and were trying to solve this issue were all engineers, and none of them had any food science experience. And so, and they had even zero baking experience, right? And it was one of those things, again, if we had had a piece of equipment like the Mixolab, we could have solved things much faster. And, you know, thankfully, they made the right choice to bring me in. But is that understanding of also the artisan skills, the tactile things, together with what that means scientifically or objectively, even if you don't have the data available, to understand what it is you are feeling or sensing. Because while it is great with experience, like Lena has mentioned, every dough is going to be a little bit unique, right? And you get used to that. And I always remember my apprenticeship is like, oh, this dough feels good. It's going to make great bread, right? Because that was the same dough we made every day, right? And so I knew what to expect. But now you throw in something different in the formula, and you still have to get the same results. But how does that dough feel different? And what is right and what is wrong? And so in the particular instance with the engineers, as I was saying, I mean, I just started to stick my hand into the mixture and just squeezing it with my hands and feeling it and just mushing it. And it took me a few minutes, and then I said, nope, don't add more water. What you need to do is cut back on the water and add a little more fat. And let's run that. Let's make another batch. Boom, problem solved, right?
Oh, that's a very good question. So we are actually working on it right now to try and propose a solution to our users. So it's not easy to do that. There is actually a lot of modifications between the previous Mixolab and this one. So whatever it is, if there is the option, it will require the instrument to be shipped back to France, whatever it takes. And also we are not sure exactly for what models exactly it will be available, for what serial numbers. My recommendation here would be to contact your local partner, contact me if you don't know who it is, to go see our website, and we can figure it out together. That's a good question. Yes, yes, it does. We have made tests with the Mixolab, well, not necessarily the 300, but the Mixolab in general for decades, and we have analyzed a lot of different raw materials. And something I did not really discuss is the versatility of the instrument. You can change whatever you want. The temperatures, the mixing speed, the water injection, the temperatures, the gradients, really everything that you want, you can modify it. And that allows us to really accommodate to a maximum of raw material. If you can make a dough, then you can analyze it.
Yeah.
So it works on corn, it works on gluten-free material. In general, we have made a couple of interventions together on gluten-free products, I think. So don't hesitate to go watch it if you're interested. Yeah, we also have worked with, I don't know, pet food and cricket flour, and now the Mixlab 300 being watertight, it really opens also a lot of different possibilities. We don't know, cheese, chocolates, why not?
Yeah, it's really cool. I mean, and even in the Mixolab 200, I mean, corn masa flour, which is nixtamalized through an alkali, um, the corn gluten in corn is becomes surprisingly functional. Not as much as wheat gluten, but it has that elasticity to it and stuff. And so it's something you can really see well on the Mixolab, even without the Mixolab 300 new attachments. It's really quite surprising. It's a very useful tool that way.
Obviously, you're going to find my answer a little bit well, not so objective, but I can say in all objectivity here that yes, you should go with the Mixolab first for a few reasons. First one is that I briefly mentioned it, but we could spend a little bit more time on that. The Mixolab is also able to provide farinograph data in farinograph units thanks to a specific protocol. And we have proven with, well, many times and with various organizations and various people have tested it, many people have tested it and also have validated it. The results are the same than with a farinograph. So you can, first of all, you can have farinograph data with the Mixolab. But then more than that, you can have much more information about how the temperature impacts the gluten. You can see the starch behavior. Again, starch is 72% of the raw material. You can have so much more information with a Mixolab than a farinograph that I would definitely recommend the Mixolab first.
I would add to that as an objective bystander that I recently got to spend time on the coast of Nice in France on the French Riviera. And if you're going to enjoy a drive along the French Riviera and you're a Ferrari salesman and you have the choice between suggesting a Fiat or a Ferrari, I think you might be suggest a Ferrari, and which one are you going to have more fun in, right? So, and I own a Fiat, and I can say that, right?
No, but I like the analogy. This is all about what you want to do. If you have a current specification system that is all based on the farinograph and you never have any problem, great. Stick
Why
with
change?
the farinograph. Why
Yeah.
change?
But if you want more information than what you can get from the farinograph, and you don't want to have 4 other instruments in the lab, then the Mixolab is really what you're going to need.
Exactly. Yeah, absolutely. Well, we have shown some example on cracker dough, which are already quite stiff. We have also worked on pasta dough. We have worked on biscuit dough, so quite stiff dough. The only limitation is the sensor. Sensor is limited to 7 Newton meters. So if we go higher than that, the system will stop itself. But again, there is a lot of versatility. So we can change the mixing speed, we can change the temperature in order to accommodate to also stiffer dough. And so far we have not found a dough type that is too hard for being analyzed. But we never know. I would say test it, try and test it. Please contact us. So I could, but we are already very close to the end time, and I would require maybe half an hour to give you a proper answer. Luckily, we have treated this topic with Bakerpedia
I was just going to
a couple
say,
of times.
Yep.
So I would suggest go to Bakerpedia website and you will find all the other seminars that we have done together. There is a couple of ones on the Mixolab already. Of course, we also have a YouTube channel, a KPM Analytics YouTube channel, where you can find also seminars dedicated to this information, to this specific information. And we do offer training, we do offer support. So please, again, if you have any questions now or after, don't hesitate to contact us.
Excellent. I have another question I want to add, since we have 2 minutes left. Is Lena, and I'm not trying to stump you, this just came to my mind when you were talking about the stiff doughs. I've re-fallen in love again in recent years with croissant making. And one of the things with laminated doughs is that you do start off with a fairly stiff dough. And so this can help you sort of see the rheology of the dough as to how it resists the mechanical adding of energy, the mixing, in other words, and which is also then the laminating that happens each time you're rolling and sheeting and stretching it and things like that, as well as the cooking and that. Now I'm wondering, is the program for the temperatures in the Mixolab set, or is that something you can adjust? And
you can adjust it.
So where I'm going with this is that the other piece of laminated doughs, especially with a butter croissant, is the butter. And there's been a lot of debates going on about this in terms of, again, it goes back to one of these artisanal master baker things, is what we call the beurrage, right? Plasticizing the butter is that you bang this butter, right? And so that you make it so it is malleable like plastic, but it's not melted. It's still cold. And it's got to do with, on a scientific level, it's got to do with the realignment of the fat crystallization and things like that. But of course, as we roll and sheet the dough, we're adding energy and friction, so it's going to warm it up slightly. Not a whole lot like cooking it, but it is going to warm. And if it warms too much, then the butter slips and it doesn't stay in one sheet. So it makes me think, as maybe an interesting project, if it ever came up, is to look at the butter in the Mixolab as to the effects of the mixing and or versus mixing and slight increase in temperature as to how that affects the rheology of the butter in terms of how much the butter can move without cracking, so to speak, right? So that's, I see a very possibly unique, interesting tool there for the artisan bakers, right? Because I mean, Bredor in France, they got it all figured out, but I mean, they make the most beautiful commercial croissants you've ever seen, right? And but who knows? Maybe a lot of that is this over there too, right? I don't know, right? But it's so something. I was wondering if you have any insights on that, as we have just a few seconds left. Right?
For making croissant, well, of course, you have the butter. That would be very interesting to test that on the Mixolab. You also have the flour.
Well, anytime you want to lend me one, just let me know.
Oh yeah, please. Well, we do have possibilities for making projects like that. So please go ahead, contact us. But what I mean is that there is a balance to reach between the fat and the flour and the fat and the dough. And this, I would say, this balance, I don't see why we couldn't measure it with the Mixolab. And butter alone, maybe a few months ago, I would have told you, no, it's not possible. But now we do have a tight mixing bowl.
Yeah, and the thing is, because the butter is really a natural based product as well. So it all depends on what you feed the cow as to the different blend of saturates that you're going to get. And so that'll vary through the season, right? And then, of course, there's these artisanal butters like Insigny from France and stuff that are very high in fat. They're like 84% butter fat, and a couple of others. And there are artisan bakers in the US who import sheets of butter from France to make croissants in the US, believe it or not, right? And it's just incredible because of that texture that they get, and it's understanding how that is made, right? And how we could maybe spread the good word amongst commercial butter producers around the world, right? Well, thank you very much, Lena. It has been amazing. As I said, it's always learned so much from you every time, right? And thank you to KPM Analytics. And so if you need anything from KPM, contact them at www.kpmanalytics.com. And my name is Mark Flurka. I'm Bakerpedia's Baked in Science podcast host, and our guest today has been Lena Boskbjorn of KPM Analytics.